In July of 2019, Elon Musk had a presentation detailing the Neuralink project. Earlier in the year, on the Joe Rogan podcast, Musk said that there was a big announcement coming, and this was it. So what is the Neuralink? Musk states that human cognition has two major systems. The limbic system, where our emotions, needs, and wants are processed, and then the cortex, which involves thinking and planning. The Neuralink in its final form is to be a third layer on top of this, a digital superintelligence layer, augmenting ourselves with computers and eventually artificial intelligence. Depending on how you look at it, we already have this layer in the form of our phones and laptops. You've all heard the saying that we have all of the world's information at our fingertips. The bottleneck in all of this is how we interface with that information. Fingers and speech are too slow and a very low bandwidth form of communication between us and our devices. A much faster way to get to this information would be directly. This is called the brain-machine interface, and the Neuralink is an effort to solve this problem. It's already been a massive multidisciplinary effort. It includes scientists, doctors, electrical engineers, surgeons, and more. So how does it work? So our brain consists of neurons firing all the time in response to electrical signals sent when we see, hear, move, talk, or think. Whenever a neuron fires from these electrical signals, a tiny electromagnetic field is present. Basically, Neuralink is going to tap into these tiny electric fields generated at synapse junctions in the brain. It's going to interpret this analog data as ones and zeros to be used in the digital world. The neuron pulses will be detected using tiny threads, about 1/10 the cross-section of a human hair, or about the size of a neuron. Each thread is to be installed with a robot, so it's not going to burst blood vessels or cause trauma. The needle for insertion is 24 microns in diameter, much smaller than the state-of-the-art in deep brain stimulation. Such surgeries had been done before for deep brain stimulation for Parkinson's sufferers, though these traditional methods have a 1 in 100 chance of causing a severe brain hemorrhage. A smaller footprint should make things much safer. The state-of-the-art for Parkinson's deep brain stimulation has around 10 electrodes. The Neuralink contains thousands of electrodes. These electrodes need to be less than 60 microns away to detect a firing neuron and serve as the interface that reads data from the brain and sends data to the brain. The processor for making all of this work is something called the N1 chip. The N1 chip reads analog brain signals, amplifies them, digitizes them, processes them, and then sends it out to a pod device behind the ear. The pod device is the only thing that's going to be upgraded, and the implants stay as they are. Remove the pod and everything shuts off. The N1 chip is 4 by 5 millimeters, low power, and has built-in hardware for processing brain signals. It can read 20,000 brain samples per second. So these are real raw signals coming from a neural link hooked up to a brain. What the scientists are looking for are spikes in voltage when a neuron fires. This is the fundamental element of communication within the brain. An algorithm can detect these spikes in real time, decode them, and make sense of the vast amounts of data coming in. The system can not only read data from the brain, but also write data. To do this, a signal is run through an electrode near a neuron, causing that neuron to fire. This kind of thing, again, isn't new and has been done since the late 1950s. It's actually the basic technology used behind the cochlear ear implant, the one that helps restore hearing. The information inputted into the brain doesn't have to be perfect because of neuroplasticity. This means the brain learns how to use the new information. Reading data from the brain and inputting data into the brain can be, and already kind of has, been used to treat things like Parkinson's and epilepsy. But future applications could include things as far as depression and chronic pain. Further applications could increase cognitive function and memory. The original plan for the Neuralink is to connect 4 N1 chips with thousands of electrodes coming from each chip. Signals will be sent via Bluetooth to the pod device behind the ear, and it will be controlled by a phone. The first goal is to get patients to be able to control a mobile device, a phone, mouse, or computer keyboard. The Neuralink will show up as a regular Bluetooth keyboard or mouse. They want to make people fully independent of their caretakers. This sounds lofty, but has already been done before with a technology called the Utah Array. With only just 100 electrodes, patients are able to text other people and control tablets with their mind. Remember, the Neuralink has thousands of electrodes, resulting in a cleaner, more reliable signal for more complex applications. The first application for the Neuralink is to tap into the primary motor cortex, the part of the brain that sends signals down to the spinal cord and onto the muscles to drive movement. It will start with simple things like a mouse and keyboard, but could also be used to read signals from all movement, even speech. And finally, it could be used to restore movement of someone's own body. The materials science team wants to use materials or properties that would make the brain not only accept the Neuralink, but think that it's part of itself. The team has already released a paper of reading, recording, and studying data from brains using their N1 chip. It's fairly controversial, but early tests on monkeys have been successful.
We wish that we didn't have to work with animals, right? That we just wish that wasn't like a step in the process. And we try to be very careful and thoughtful about it and do it as efficiently as possible. Because we believe that the benefit to humanity is in the end, like the benefits outweigh the negatives.
Yeah, I mean, but we have made a monkey has been able to control the computer with its brain. Just, FYI.
I didn't realize we were running that result today, but there it goes.
Human patient trials are set to start by the end of 2020. The target patient will be a quadriplegic due to a spinal cord injury. The main hurdle so far has been FDA approval for implantable devices. So the future of Neuralink will be in 3 stages. Stage 1 is to understand and treat brain disorders, starting with people with serious medical needs. Stage 2, preserve and enhance one's own brain. Stage 3, full brain-machine interfaces. In the future, there could even be a kind of app store for programs that you can download and control with your brain. Other possibilities from the presentation include a new kind of communication, kind of like telepathy, or downloading the memories of someone who's familiar with a city so that when you go to that city, you feel familiar with it too. The possibilities are kind of endless. But of course, these are the very early days, and we hardly understand anything about the brain right now. Although what the Neuralink is basing itself off has already been done in the medical field for decades, what they're proposing is a giant leap above all of that, and it's going to be a long road to get there. So some obvious questions remain. Is this ethical? Should we do this? What about the risks? Well, for that last one, in terms of risks, for Parkinson's deep brain stimulation and other such procedures seem to be much more risky. Though there's not a lot known about what the kind of technology that Neuralink is proposing could lead to in its full form. So what do you guys think?